Hello and welcome to your lesson on resistivity. So if you can please title and date, that would be fabulous, and then I shall talk through the notes. So, when we did our lesson on resistance, we talked about different factors that affect resistance. We talked about, temperature, we talked about length, we talked about area, and today we're going to be looking at an equation which tells you how much resistance different materials have. So, factors that affect it: length, cross-sectional area, and the material that electricity flows through. So, as I know you know, if we put a piece of plastic into a circuit, that's going to have a very high resistance in comparison to a piece of copper, for example. So, length. As length increases, resistance increases, and that is because resistance is proportional to length. That means if you double one, you double the other. Cross-sectional area. As if area increases, resistance decreases. They are inversely proportional. Now that means if you double one, you half the other. So, double one, half the other. That's what inversely proportional effectively means. So, an equation. R is resistance, and that equals rho, which is a Greek letter, L over A. Rho is something called resistivity, and it basically tells you how much resistance a certain material provides. So it's specific to a material. So we've got an official definition here: a property of a material that is measured as its resistance to current per unit length for a uniform cross-sectional area. So that's like if you had 1 metre length of this with a 1 metre squared cross-sectional area, what would be the resistance? It is measured in ohm meters. Basically different materials have different resistivities. The higher the resistivity, effectively, the more resistance it's providing. L is length, and that's measured in meters. Area is meters squared. Just a quick note about area. For a wire, or obviously any type of circle, remember that it is pi r squared. Notice that that's radius. The reason I'm bringing this up is this is not a hard equation. However, there is a lot of things that can go wrong in it because it's quite fiddly. And by that I mean you've got length, which should be in meters. Well, that might be in centimeters, millimeters, etc. You have area, which should be in meters squared. But again, they won't tend to give you the area. They'll give you a radius, or they'll be even more tricky and give you a diameter. So it's just stuff you really need to spot. Make sure you're up on your prefixes. Make sure you're looking out for diameter, radius, etc. So let's do a practice question. Now, this is actually the second time I'm filming this video because the first time it didn't save, which is very frustrating, which means I have in fact written the answers to this practice question already. So what I'll do is I'll talk you through them. So, practice question. A wire of uniform diameter 0.28 millimeters and length 1.5 meters has a resistance of 45 ohms. Calculate its resistivity, which is what I did in that top bit up here. So I did the equation R equals rho L over A, but I want to work out resistivity. So I've rearranged it. So rho is RA over L. I then put in R, which is 45 ohms. A is the area, which has got to be pi r squared. Now notice, you're given a diameter, 0.28 millimeters. So the first thing I'm going to do is half it to get radius. Then I'm going to make sure I use a prefix. So for the area, I've put in pi times 0.14 times 10 to the minus 3. That's effectively 0.14 millimeters squared. Again, people will forget the squared, so please make sure you're doing that. Divided by length, which is 1.5. Popped it into my calculator and it came out as 1.85 times 10 to the minus 6 ohm meters. Okay, next bit, I had to say the length of the wire that has a resistance of 2 ohms. Now the first thing to remember is I've just worked out the resistivity of that wire, so I can use it. R is rho L over A, rearrange it for length. L is RA over rho. This time resistance is 2 times, again you've got to work out the area, so pi times 0.14 times 10 to the minus 3 squared, over rho, the resistivity, 1.85 times 10 to the minus 6. As worked out in part A, plugged it into my calculator, and I got 0.067 meters. So please come join me on Zoom. There's a worksheet to do and some summary questions. Thanks everyone.